Good morning and good afternoon. What's up, everybody? Welcome to the Jovian Astronomy Podcast, where we dive into, the fun facts of space and astronomy, and all the wonderful things that come with it. Today we're going to be going over the difference of a comet and an asteroid. I don't know if you guys know the difference between, so we're going to do, I don't know if you've ever known the difference between a comet and an asteroid, but today we're going to learn, folks. So, let's do this. Let's get right into it. As you know, meteors and asteroids, more mainly, they're made of rock, they're made of iron, they're made of things that are, not really so much of a icy, snowball type of effect, but, actually, let's stop. I'd like to see how everybody's doing for a minute. As you know, I've had this podcast for a little bit. I love doing it to death. It's one of my favorite things. I've recently had a couple things happen where I haven't been able to do it as much as I want, but I am getting myself back into it. Trying to at least keep a couple things going. I also recently moved, which is a big thing because I've started to do where I started to actually, instead of doing like live ones all the time, I started doing where I pre-record, long, better episodes and stuff like that. But go to my website on here, check it out. I put up, the what's coming up in the sky, for the month, and different stuff that's coming up. That you can look in the sky if you have a telescope or binoculars and like to look at, different things in the night sky. When full moons and stuff like that are. But definitely go and check out my Patreon page if you like what you do here and you learn. Check out my Patreon page. Anything always helps. I always, love the hell out of doing all this. I appreciate any support that you guys give, to even just listening is awesome, for you guys. For me, So anyway, let's get right into this, guys. I hope everybody is doing well. Now, asteroids, comets, meteors, and meteorites. A compilation of educational materials about asteroids, comets, meteors, and meteorites, including resources for Asteroid Day, meteor showers, and links to NASA missions, such as Lucy, OSIRIS-REx, Psyche, Double Asteroid Redirection Test, DART, in other words, and Near-Earth Asteroid Scout, NEA Scout. It's, I used to not know the difference so much between what asteroids, comets were. Recently, I've, understood them and what they are. Not recently, I'm sorry, but, I've always kind of, I know. Oh, what is that? Hey! Yeah, I know. So,
10, 9, 8,
here's the go.
7, 6,
This is it.
5, 4,
It's going.
3,
It's going.
2,
It's going.
1.
Oh. What is the difference? I know. Thank you, guys. I love you too. Now, so what is the difference? An asteroid is a rocky object that orbits the sun. Asteroids, they're smaller than a planet, but they are larger than a pebble-sized object we call meteoroids. Meteoroids. Oh my god, I can't say. Meteoroids. And comets are small, icy dirt balls that orbit the sun. Comets are made of ice, dust, while asteroids are made of rock. Is usually the difference. But a meteor is a space rock or meteoroid that enters Earth's atmosphere. As it burns up upon entering Earth's atmosphere, it's creating a streak of light in the sky, often called shooting stars, as you would probably know them, shooting stars. When Earth encounters many meteoroids at once, we called it a meteor shower, or when it's going through the tail of a comet. Boy, that's a good Clutch. You've ever listened to Clutch? Great band. If you haven't, check them out because they're a wonderful band. Space Grass is a great song. In the tail of a comet. Yeah. Anyway. And please feel free to call in. I love it when people call in. If a meteoroid survives a trip through Earth's atmosphere and lands on Earth's surface, it's called a meteorite. So if they actually land on Earth, which we find a lot of them, and a lot of them are found in Antarctica. And it's only because, it's not because they fall in the southern part of the world, it's because Antarctica is all white. It's all ice there, so they stick out like a big sore thumb, So now discover all our near-Earth objects, asteroids, and comets using NASA eyeballs. Now, through the NASA's Eyes on Asteroids visualization tool, you can now explore the asteroids and comets that approach Earth's orbital neighborhood and the spacecraft that visits these objects. With a click or swipe, thousands of asteroids and dozens of comets are discovered every single year, some of which, called near-Earth objects, NEOs, follow orbits that pass through the inner solar system. With their numbers rising daily, these objects are tracked carefully by NASA-funded astronomers in case any might pose an impact threat to our planet. Now, the daily updated Eyes on Asteroid depicts the orbits of every known NEO, providing detailed information on these objects. Using the slider at the bottom of the screen on this particular oh god, what am I trying to say? You can check. I'm posting that on my website, so you'll be able to check it out and see it. It's actually really, really, really cool. Asteroid Day is each year on June 30th. And I can put these. Let me put these. Let's see. I'm going to put these in the thing so you can. These links so you can check them out. Pretty cool. Here's one link. Here's that. There's another link. Let's see, copy link. Put that in here as well. That way you guys can check these out. Oops, that's not what I fucking wanted to do. It is what happened, isn't it? Yes. I wonder if, I hope that you can hear my voice. I don't. I'm not real sure if you can. Anyway. Now there's a Perseid meteor shower. The Perseids are the most popular meteor showers as they peak on warm August nights, as seen from the northern hemisphere. Check out the astronomical events calendar. Now, let's see, where was I? I've got a bunch of different things to check out. Actually, this is a huge thing for different what am I trying to say? Different. I cannot think today. I apologize. they're different lengths. God, I cannot talk today. I feel stupid. Yeah, like, normally. Just a retard that I am. Now, the difference between asteroids, comets, and meteors, as I said, these space rocks, they each have their own unique attributes. But differences aside, these fascinating objects are all worthy of study. Well, they're all planetary objects orbiting the sun. An asteroid is a small rocky object, and when seen in a telescope, it appears as a point of light. Most asteroids are found in a ring between the orbit of Mars and Jupiter called the asteroid belt. Now, I mean, there are some near orbits. The ones that fly, just that are constantly around, flying around Earth, the ones that they always freak out about, but they're not. Those are the NEOs, but some asteroids are round, some are elongated, and some even have satellites. Little like moons that circle around them. A comet also orbits the sun, but unlike an asteroid, it's composed of ice and dust. So when a comet gets close to the sun, its ice and dust content start to vaporize. And that's where this tail comes from. So when seen through it in a telescope or a naked eye, a comet appears fuzzy, and it's got a long tail. It could be millions of miles long. It's really amazing. If you've never seen a comet, check out my website on Podbean, because I've got a list of when some of them are coming and when you can see them and stuff. They're amazing. So what's a meteor? We all ask ourselves. Well, let's start with the meteoroid. A meteoroid is a small piece of asteroid or a comet, typically pebble-sized, but could be a little smaller or a little larger, and often created from a collision. When a meteoroid gets close to the Earth and enters the Earth's atmosphere, it's called a meteor. And a meteor enters the Earth's atmosphere at a very high speed, so it burns up and produces a streak of light called a shooting star. So if you've seen a shooting star, you'll likely saw a meteor. And if a meteor survives the burn and lands on the ground, it's called a meteorite. So that's kind of the difference between, those two. It's, the longest time I didn't know, but the main difference between asteroids and comets is their composition, as in what they're made of. Asteroids are made up of metals and rocky material, while comets are made up of ice, dust, and rocky material as well. But both asteroids and comets were formed early in the history of the solar system, about 4.5 billion years ago. Asteroids formed much closer to the sun, where it was too warm for ices to remain solid. Comets, they form farther from the sun where ice, would not melt. And comets which approach the sun lose material, which each orbit, because some of the ice melts and vaporizes, which is where the tail comes from. You can check out, there's so many videos too on YouTube that have some really cool videos of them. But celestial bodies like asteroids and comets are time capsules, man, basically. I mean, they contain information about the history of our solar system, making them interesting targets for studies. The main difference between asteroids and comets is their composition. As I said, asteroids and comets are debris left over from the formation of the moon and planets and other things. Comets are located in the outermost regions of the solar system, while most asteroids are located in a belt between Jupiter and Mars. The comets are usually in our Kuiper belt or in the Oort cloud, which are way, way, way further out than Pluto and stuff. Occasionally, comets and asteroids change their orbital path due to gravitational disturbances, sometimes bringing them close to a planet. Craters on the moon and planets are evidence of histories of impacts, with comets or asteroids, like the one that killed the dinosaurs. Comets are made of ice dust, ice, rock materials, while asteroids are composed of rocky materials and metals. Both celestial bodies formed 4.6 billion years ago. Now, these asteroids were formed much closer to the sun, where it was impossible for the ice to remain solid. Comets were formed far away where the sun, where the ice remained solid. Comets that approach the sun, they lose material every time, as I was saying, they orbit. And they're, what that tail is known as the coma. Asteroids orbit the sun and are small bodies in the solar system. They're made up, as I said, I'm basically saying it over and over. Comets also orbit the sun, but they're relatively small bodies. The ice and compounds like ammonia and methane develop a fuzzy cloud. When some parts of the ice melt, the others materialize vaporized due to the heat of the sun. It results in a glowing halo that extends outwards as through sailing through space. This is a notable difference between comets and asteroids. Now we have an idea of what asteroids and comets are. Let us write down the differences between them in a table. The comparison between asteroids and comets. So, the difference, asteroids have an elliptical orbit, like comets. Comets have an eccentric orbit. Asteroids is made of metals. Comets, they're made of rocks, hydrocarbons, and ice. Asteroids do not produce a coma or tail atmosphere. Like comets, they produce thin temporary atmospheric tails when close to the sun. Asteroids are orbital period to 1 to 100 years, and comets, their orbital periods are 75 to more than 100,000 years. Asteroids are 1 to larger than 100 kilometers in size usually. While comets are 1 to 10 kilometers in size, nucleus only. The just now mentioned points were a few differences between comets and asteroids. We know that the Earth has been hit many times by comets and asteroids whose orbits bring them close to the Earth. Now there's been evidence proving that cosmic collisions played a major role in a mass extinction. Through none of the time posed a threat to Earth as of now, but 2029, it's getting scary, I think. You can learn more of the differences between various celestial bodies, like the difference between meteors and meteorites, by BJUs. And I will put that at the bottom of the right there. So I can put that here, and put that there, so you can see that. And boom. Okay. So yeah. I don't know. I always think it's pretty cool the way that they. I don't know. Let's see what I'll say. Now, a compilation of educational materials about asteroids, comets, meteors, and meteorites, including resources. For asteroid day meteor showers. I've got a list of stuff that's pretty cool. How you can make your own comet, sort of, kind of. It's pretty rad, really. Now let's get into, let's see, are any comets? What was it? Hang on, let me get my list of stuff. Yeah. So, this is kind of, now notable asteroids impacts in Earth's history. Gets interesting. Throughout, Earth's history, there have been many instances of near-Earth objects, NEOs, impacting our planet, either reaching the surface or exploding above the ground from the intense energy released as the object passed through the atmosphere. Asteroid impacts are natural processes that shape the surface of our planet, like volcanoes, usually. And the vast majority of these impacts were from very small objects, but there have been some pretty remarkable exceptions. In 2013, I believe the Shelley's Binks event. What's that? Huh? Oh yeah, the Shelley Binnis. I can't remember event. Was it that one in 2013 when the asteroid, about 20 meters in diameter, entered Earth's atmosphere above the city of? It was in Russia. Thank you. Oh, thank you. Thank you, man. You're awesome. I owe you. Yeah, I do. I got to. But yeah, man, that one was pretty cool. I'm crazy, I should say, I guess. I don't know. It's pretty scary, man. That was the one in Russia. It exploded while it was still in the air, releasing the same amount of energy as 500 kilotons of TNT. Luckily, it exploded about 30 kilometers above the ground and did not cause direct impact damage. Still, it created a shockwave, though, that injured 1,500 people and damaged 7,200 buildings across 6 cities. Most of the injuries were caused by curiosity. People saw the bright flash and walked to the windows to look outside, which I can't say that I wouldn't do. You know what I mean? The shockwave and traveling at the speed of sound arrived later and shattered the windows, injuring people with flying glass. I can't imagine how. Yeah, that turned out for anybody. Nightmare. Then there was a Tunguska event. That was in 1908. You think that like nobody was around, but it was definitely, there were people around. It was pretty notable. Big deal. It was approximately 30-meter diameter asteroid or comet entered the atmosphere and exploded above ground in Tunguska, Russia. The explosion knocked down approximately 80 million trees over an area of 2,150 square kilometers or 830 square miles. This explosion has been estimated to at 1,000 times more powerful than the explosion of the atomic bomb in Hiroshima. Had this taken place over a metropolitan area, the city would have been completely destroyed. Luckily, it happened in a remote area of Siberia, when nobody is thought to have been killed in that one. I mean, it's so vast, Then there was a Chicxulub event. This was, of course, 65 million years ago. Of course, this is the big one. Roughly 10 to 15 kilometers or 6 to 9 miles in diameter hit Earth in what is now New Mexico. I wanted to go to this one. Now, this impact killed 70% of all species on Earth, including the dinosaurs. An impact of that size would have had devastating effects, and geological records gives us some indication of what happened. The asteroid hit the water, creating mega tsunamis, reaching from southeastern Mexico all the way to Texas and Florida, and up a shallow interior ocean that covered what is now the Great Plains. That's pretty crazy. The blast would have thrown chunks of asteroid and Earth so far that they would have briefly left the atmosphere before falling back to the ground. Like millions of shooting stars, all this material would have been heated to incandescent upon re-entry, really heating Earth's surface and igniting wildfires. It is possible, that all of Earth's forests burned. Pretty sure. Meanwhile, colossal shock waves would have triggered global earthquakes and possibly volcanic eruptions. A cloud of superheated dust, ash, and steam would have spread from the crater as the impactor slammed underground in less than a second. God, that's nuts. Can you imagine how big that, I mean, seriously? But this dust could have covered the entire surface of Earth for up to a decade, creating a harsh environment for living things. Perhaps more significantly, the dust could also have lingered in the atmosphere, blocking out the sun and interrupting the photosynthesis of planets that the entire food chain depends on, as well as cooling temperatures of the Earth for many years. Now, the next event, I got to take a break, but don't go anywhere because the next event, man, is pretty harsh. But shall be right back. So do not go anywhere. Please. I'll be right back.
So just in case y'all didn't know, the government is actually lying to us and stealing from us. The last stimulus check that you got. In 1972, Eugene Cernan led the sixth and final moon landing. So, as the crew headed back to the module, Cernan gave a speech promising that people would definitely return to our satellite. However, Cernan never got to see new missions to the moon and became the last person to set foot on its surface. Nevertheless, after a stunning hiatus of over half a century, NASA's planning a new lunar mission in 2026. Some people believe this landing will be the real deal, unlike all the previous ones. But what's the basis for such claims? In this video, you'll find out which shots from the moon landing are genuinely fake. Why was Buzz Aldrin forced to take a polygraph? Could the Soviet Union debunk the U.S. moon landing conspiracy? And most importantly, are they really hiding the terrifying truth about the moon landings? Many Americans still believe the moon landing was fake, even though 600 million people watched the first landing live in 1969. But just 7 years later, the world's first moon conspiracy theory emerged, and its author was none other than NASA engineer Bill Kaysing, supposedly.
Welcome back. Right after a short break. Okay. So the next event goes into, although immense impactors like the one that devastated the entire planet 65 million years ago are rare, NEOs of many different sizes can pose serious threats. An impact on or over a densely populated city could cause millions of deaths. And an impact on water could cause massive flooding in coastlines. Now, any major impact would lead to widespread damage, injury, and death, and would create unparalleled humanitarian and refugee crisis around the world, especially now with as much as we use, satellites and stuff like that. But now that we have we've figured out defending the Earth from impacts, asteroids and comets that come close to Earth can pose a very real threat to our planet. But impacts from these objects are inevitable. With proper planning, we can prevent this natural disaster from happening. Like when you become become a member of my podcast, you join our mission to increase discoveries in our solar system and beyond, elevate the search for life outside of our planet, and decrease the risk of Earth being hit by an asteroid. So please. Now, how we defend the Earth from impacts is pretty cool, man. It's a lot of planning, but it's pretty cool. Asteroids and comets that come close to Earth can pose a very real threat to our planet, but impacts from these objects are avoidable. But what is the threat? There are billions of comets and asteroids in our solar system. The vast majority never approach Earth. When a comet or asteroid orbit brings it close to Earth, it is classified as a near-Earth object or an NEO. Early Earth was bombarded by comets and asteroids, some of which may have carried water and carbon-rich materials that helped kickstart life, possibly. Today, impacts still happen all the time, but are most barely noticeable, really. Earth's atmosphere burns them up, most of the objects that collide with the planet. Impactors large enough to reach the ground are rare, but it does happen. And although infrequent, most major impacts are possible and can create more damage than an atomic bomb. A big enough impact could wipe out the entire cities or even cause global devastation. Notable asteroid impacts on Earth, there's some of the most significant impacts that humans and dinosaurs have witnessed. Now, what is the planetary defense? It's pretty cool. Although devastating impacts are very rare, there are also cosmic inevitability if we don't take steps to prevent them. Planetary defense is the effort to make sure that major impacts don't happen. Defending our planet from NEOs takes 5 steps. 1, find it. First, we got to find it. We can stop asteroids from hitting Earth, but first, we have to find them. The sooner we find the threatened NEO, the more options exist to prevent an impact. The probability of a comet impact is about 1% of the probability of an asteroid impact, which is part of the reason planetary defense tends to focus on asteroids. Asteroids are also easier to find than comets. Researchers around the world are finding asteroids at an ever-increasing rate now, though. I mean, it's pretty crazy. In the 1900s, there was one known near-Earth asteroid. The 1950, there were 13. In the year 2000, there are 879. And since then, we've made huge progress in finding NEOs. As of 2021, we have found more than 25,000 in total that are constantly, circling Earth and stuff. It's crazy. And they do pose threats. It's pretty nuts. We don't hear about them, but there was one real close, I think, what was on Christmas Day, this last Christmas, that ended up being a bigger scare than they thought. Now, the second step 2, after finding them, is tracking them. Even if we find near-Earth objects, how do we know if they're going to hit Earth? We need to track it and map out its orbit to very high precision to predict whether its path will cross our own at the wrong time. Or the right time, how you want to look at it. To do this, astronomers make thousands of telescopic observations over days, months, and years, each of which helps to refine the predicted future path of a comet or asteroid that they find. NEOs can even be lost if their first detection isn't followed up quickly. Their orbits are also uncertain. We don't know where and when to find them again. So, if we don't know where they're going, a lot of times you can use a computer, and they'll generate a program that'll show, where these are going to go, and it'll show, if they're going to hit Earth. Lost NEOs are more likely to be small ones because they're quickly become too faint to see from Earth. Now, after we just find it, to track it, and we go to step 3 and characterize it. See how it is, see how big it's gonna, see what it's going to be they characterize them in size. And to understand specific asteroids and comets in case we need to deflect them, we need to characterize the objects we find. By collecting many observations, we can determine things like spin rate, composition, which is spin rate, and it can tell us how much kinetic energy is going to hit, when it hits Earth. By collecting these observations, we can determine things like the spin rate, composition, the physical properties, and even whether what at first appears to be one object is actually two. Asteroids or comets, they're a highly varied and even factor, can affect how best to plan a mission to deflect, one that is threatening Earth. The Gene Shoemaker Near-Earth Object grants, we'll get into that in a minute, but the Planetary Society Shoemaker NEO grant program provides grants mostly to amateurs to assist with observations critical to finding and understanding near-Earth objects. Past Shoemaker grant winners have made tremendous contributions to discover, tracking, and characterization of potentially dangerous near-Earth asteroids using the upgrade facilitated by the grants. So that's pretty cool. Now, after that, you go to step 4 in deflecting. Once you know what it is, once you've tracked it, once you know what characterization it's going to be under, then you can learn how to deflect it, which is in step 4. And if or really when an asteroid is found to be on a collision course with Earth, can we push it out of the way? Well, if we detect the NEO many years before a predicted impact, we would not have to deflect it much. Really, just a few minutes change its arrival time at Earth's position could be the difference between an impact and a near miss. A tiny impulse to an NEO many orbits before a predicted impact could prevent the impact from even happening. Right now, there are several possible techniques and variation states of readiness, but all need more development and testing. Even when developed, it will take years to put a deflection mission into action. We need to do that development and testing before an incoming object is actually detected, and not after. Then we go to step 5, and that's coordinate. No matter how you look at it, a comet or asteroid impact is an international issue that requires international coordination. As a first step, global education about the NEO threat is required at all levels, from policymakers to disaster management agencies to the general public. It's important for all to be aware of the level of threat and how it can be prevented, and then defend the Earth. Planetary defenses is one of the Planetary Society's core enterprises. Learn more about the work we're doing, defend Earth and its impacts. When we become a member, you get to join them now. We will go into some of the defend Earth things, like decrease the risk of Earth being hit by asteroid or comets. The challenge is the Earth shares its solar system with billions of asteroids and comets. The vast majority orbit and sun far from from our planet. Those who orbits approach our own are called near-Earth objects. As I said, the vast majorities are harmless and pose no threat. However, most people are aware of large near-Earth objects that devastated the entire planet 65 million years ago. While rare, these kinds of planets are still kinds of impacts are still possible. In fact, NEOs of many different sizes can pose serious threats. An impact on or over a densely populated city could cause millions of deaths. Obviously, and an impact on water could cause massive floodings on coastlines, which lead to death. Any major impact would lead to widespread damage, injury, and death, and would create unparalleled humanitarian and refugee crisis around the world. Good news is an asteroid or comet impact is a natural disaster we can actually prevent if we try. The effort to prevent asteroids or comet impacts is called planetary defense. the education and outreach, we help more people understand the reality of the danger and the importance of protecting the Earth from asteroids, and we help them share the knowledge with the family and friends. We share, different ways to help. So anyway, there's a couple things on some differences of comets, asteroids, and meteorites. So I hope you learned something today. If you did, please hit follow. Please hit like and follow me. I appreciate everybody's help. Check out my webpage. My website on Podbean, and definitely hit like and follow, and check out my oh my gosh, what is that? I can't believe I'm so dumb. Yeah, some days, God, I just say, I cannot speak, I cannot think of things. Anyway, check out my Patreon page, if you get a minute. I always love the support. You guys are awesome, and look up, I will be posting more shows to come. I usually do them on Mondays, Wednesdays, and Fridays, but then I'm starting to get into where I can do more. So you guys have a wonderful weekend, and I hope you learned something and to know events.